G'day and welcome to the Tech Math channel. What we're going to be having a look at in this video is we're looking at using trigonometry. We're looking at in the last video, and using this trigonometry to solve for unknown sides. Okay, work out unknown sides. So first off, let's just go give a quick recap of what we had to look at last video. We had to look at first off how to name the different sides of a trigonomic triangle, okay, right angle triangle. And when we're using trigonometry, we have a couple of different names for the different sides. So say we have this angle here, we call it theta. We have the long side here, which we call the hypotenuse. We have the side opposite theta, which was called the opposite. And we had the adjacent side here, which was called adjacent. Okay, so H, O, and A. And then we had these trigonomic functions. Okay, the trigonomic functions, you're going to see here we have, I'll just put the calculator up here. This is the calculator on your computer, by the way. If you don't see this particular one, you might see it more like this. You can hit view and go to scientific. And if you do this, you're going to notice that these three buttons here, we have sine, cos, and tan. And a lot of scientific calculators have these as well. We're going to be using these three trigonomic functions, sine, cos, and tan. And so the functions are as follows. We had sine, cos, and tan. Okay, sine, cos, tan. And these functions, these ratios are as follows. The way I remembered it was this. So I remember this little mnemonic called some old hags can't always hack their old age. I'll write this, some old hags can't always hack their old age. Okay, so we have, so we have theta, and with the sides we're going to be playing around with the opposite and hypotenuse. We're going to be using sine. Alternatively, we might be having theta, and we might be using the adjacent and hypotenuse. In that case, we'll use a cosine. Or if we're using theta and these opposite and adjacent sides, we're going to use tan. Okay, so we're going to be using these to solve some unknown sides right now. So first off, I'm going to put a list of rules I reckon that we are going to follow when we solve these. Okay, first off, we're going to, for our particular problems, we're going to label the sides. We'll then work out the trigonomic function, which one of these particular ones here we're doing. And then what we'll do, we'll substitute values in and then solve our equations. So let's do this right now. So say we had this particular problem here. It's a nice looking problem. It's a beautiful problem. It looks a lot like this, okay? So it's a triangle. It's a right angle triangle. I'll put the little right angle doobie wacky in there, okay? And what we have is we have theta here, which is going to be, let's call it 30 degrees. We know the side here, which is 8. And I wish to know the opposite side here, which I'm going to call x. Okay, so how do we solve this? Now, first off, we have to label our sides. Okay, so when you do these, really follow these steps through. So it's really important that you know how to do each part. So first off, you should be able to label the sides. We have theta, we have the long side, which is called the hypotenuse. We have the opposite side to theta, called the opposite, and we have this adjacent side. So which particular ones are we using? We're using the opposite and the hypotenuse. So you might remember we had some, so first off we've labelled the sides and we now work out the trigonomic function. So some old hags can't always hack their old age. Okay, which one are we going to be using? Well, as you see, we're dealing with the opposite and the hypotenuse. So this is the sine here. So we're going to be using sine. And so we'll write that out a bit nicer than this now. Okay, let's write this out properly now. So the rule we're going to be using is sine equals opposite over some old hags, opposite over hypotenuse. Okay, so the way that we actually write this now is we write sine. And the sine of what? Sine, you say? It's a sine of 30 degrees. So 30 degrees is the thing we're going to be using sine with, and it's equal to the opposite, which is x, over the hypotenuse, 8. Now before we do anything, let's get x all by itself. So what can we do to do this? Well, at the moment, this side's dividing by 8, so if we just multiply this side by 8, we're going to get rid of it, so we also have to multiply this side by 8. Okay, another way I occasionally want to do these is just to chuck another random little thing in, and it's a really handy thing when if you get stuck on these, is this. I actually write this equation down here, 3 equals 6 over 2, or 2 equals 6 divided by 3. This means this number equals this number divided by this number, and it's true, yeah? It's also the same sort of format as this here. We're trying to find out this number up here, where the x is. So what would we do with, if it was this 6 here we're trying to find out, we would multiply these two numbers. So we're going to multiply these two numbers. Okay? That's just a little trick I use. Okay, so to work out x, we're going to multiply sine 30 times 8. So let's do this. You might have a scientific calculator, but I'm going to use this calculator here. Okay, so it's on the scientific mode. So let's do this. We'll type in 30. We hit sine, which is 0.5 times 8 equals 4. Okay, so our answer is x equals 4. Okay, how did you go with that? That's a nice, easy one to start off with, okay? All right, let's go through another example here. So, yeah, that's our answer. Let's go through another example. And no, I'm not just going to make it so it's necessarily going to be, the next one's going to be a cos one, and the next one then after will be a tan one. I think that would be too easy, okay? So, I'll try to be fairly random with them, okay? Oh, yeah, okay, yellow triangle, that's fairly random as well. What about we do this? I'll do this line here, and I'll make this actually a little bit bigger so we can see what's going on here. Okay, let's put some side lengths on this. So first off, yes, this is 90 degrees. Let's make theta here, let's make it 66 degrees. Okay, and we're going to try and work out this side, x, and we know that this side here is 15. How's that sound? Alright, that's a good little random one. So first off, let's label the sides here. So we have the long side here, it's the hypotenuse. That's the one we're not going to use, eh? We're going to have the opposite to our angle here. This is the opposite. And with the other one, which is running alongside, is the adjacent. So we've labelled our sides. Now we have to work out the trigonometric functions. So some old hags can't always hack their old age. Which one are we dealing with? Well, we're dealing with the one that's not the hypotenuse, so it's not this one, it's not this one, it's tan. Okay? So let's write this out nicely now. Okay? So we'll get rid of those, and we have, here we go, we're going to have tan equals their old age. So tan, 66 degrees, equals the opposite, which is 15 over the adjacent, which is x. Okay, so I'm going to do that similar sort of thing again, where what I did was I wrote, because this one there, you can get x by itself by multiplying over here. We have to get x by itself, then, don't we? So what I'm going to do with this is I'm going to rewrite this thing up here. So 3 equals 6 divided by 2. Okay, so we're trying to find the one down here, this 2 value one. Okay, this one here. So what we would do to get this 2 is we'd go this one divided by this one. Okay, so this one divided by this one, this one divided by this one, this one divided by this one. Okay, so x equals this one, 15, divided by tan, 66 degrees. Okay, let's do this. Calculator. clear, and we'll go 15 divided by 66 tan equals 6.67. Okay? 6.67. So, how'd you go with that one? Pretty good? Okay, if you're not 100% sure when you're doing these, maybe what you want to do is you want to go 66 tan. You might want to put that into the memory, so memory plus, and then you can go 15 divided by memory read equals 6.67. In fact, I should be rounding that up to 6.68. It's going to be more correct. Okay, 6.68. Okay. Did you go good with that one? Let's just do one last example here. Hopefully it's a... Yeah, okay. Look, I'll make it a cos one. You know I'm going to do it. Well, I suspect I'm going to do a cos one. Maybe I'll be a little bit tricky and we'll make it something that's not cos. Let's have a look. It doesn't really matter, does it? Okay, so what about we do one last one here, and we do this. Here's my triangle, and, oh, it's a nice, good, lofty sort of triangle, big, long sort of triangle, I mean. And this one here is going to be, I'm going to call this one here, what about we call this one 18 degrees. I'm going to be doing, in fact, we're going to do, let's make it a cos one. How would I do that? Let's work that out. We're going to go, can't always hack. It's a bit of a reverse engineering, isn't it? Okay? So we're going to have to do one, which is going to be the adjacent, which is this one running alongside. So let's make that 7. And the hypotenuse, that's going to be x. Hey, how's that? Now you get the mindset of how a teacher works. No, it's insane, isn't it? So, let's go through the motions anyway and work this out. We know it's going to be a cos one, but let's work it out anyway, as usual, because it's a good method to be into. Let's label the sides first. So the opposite over here, we have the hypotenuse, and we have the adjacent. And now let's work out the trigonometric function. So we know that some old hags can't always hack their old age. Okay, we're dealing with the always hack bit, so we are dealing with cos. Good, it all worked out. So cos 18 degrees equals always hack A, which is 7 over x. Okay, I've taken a bit of a shortcut there already, okay? So let's get x by itself, okay? So I'm going to write that similar sort of thing up where 3 equals 6 divided by 2. And this time the one we want is we want the one down here. This one down here, which equals this one divided by this one. This one divided by this one. This one divided by this one. So x equals 7 divided by cos 18 degrees equals, let's work this out now. Okay, 7 divided by 18 cos equals 7.36. Alright, cool, 7.36. And occasionally you can look at it and say, is that that's actually the hypotenuse there? That makes sense. It's a longer sort of length there. And it's a pretty shallow sort of angle, so it's not going to be a huge amount longer. So it's a fairly reasonable sort of answer. So how did you go with this? Pretty good? Hopefully. Anyway, in the next video we're going to be having a look at working out, using sides to work out unknown angles. Yeah, it's not much of a tweak. It's actually using a very, very similar sort of rules here. Okay, so I hope to see you then. Bye.